All right. No, I'm starting. If you're walking in late, you need to quietly get it together. I got things I need to do. Do not complete 9 through 12 later. We're not going to learn it. It's not a trick. Okay? So just don't bother with it. Okay? I'm telling you that. You should have a graphing calculator. You should have a ruler. We are not going over the homework because there isn't time, and honestly, I shouldn't need to go over it. I need you to jump right to the classwork today. Plenty of stuff to do. Okay? Our pet of the week came from period 2. It was by the time a dog won. And cats had won all the other ones. Yeah, good time. Okay, so. It's time. Okay. The very first thing you should do is you should pick up the graphing calculator, clear the memory, and then put it aside. You will need it again in a little while, but not for a bit. Second plus 712. Little friendly reminder. You will need a graphing calculator to complete a lot of these assignments at home. You cannot take mine home, so hopefully you know where it is. But you can always use mine here during class. Okay, so it's not necessary you bring it from home. Okay, so you should be open right up to thigh 7. You should be right here. Right here. Now I kind of got this done in period 2 despite the 20-minute escapade outside. So we should be able to get it done here, but it does take some time. Okay, we're going to talk about scatter plots and trend lines today. I believe like plotting coordinate pairs. You probably did this in like 3rd grade. When did they teach this stuff to you, like plotting these points? 3rd grade, maybe? I don't know. Go ahead and plot the points. We got 2, 3, -1, -2, 0, 2, -2, 0. Is it like, it's like 3rd grade when they teach this to you? Probably. Maybe some of you earlier. Maybe some of you earlier. I don't know. Okay, maybe not the negatives. Do you know your quadrants? This is 1. Add 2. 3, and then 4 over here. There's like 2 places where they still use Roman numerals. I think this and Super Bowls. I don't see them used anywhere else. Okay, cool. What you actually are going to look at today is not plotting stuff like this, moreover stuff like this. Okay? How many of you have heard of this word before? Correlation. Has anybody heard of that word before? A little bit? Has anybody never heard of the word correlation before? Is anybody not sure if they've heard of the word correlation? Those are kind of the only options. Okay. We're going to talk about it a good bit today. We're going to do some stuff without the graphing calculator. Then I'm going to show you a couple cool things with the graphing calculator. Makes for a full lesson. A correlation is a measure of strength of relationship between 2 quantities. It's like, what do I mean? Look at that graph up there. What is it showing? The relationship between temperature and ice cream sales, particularly. Is there a relationship on that, did you say? Yeah. How would you describe the relationship? I'm not trying to trick you. Okay, Dante. Yeah, this is not a trick question. According to the graph, and you would believe this in life too, the higher the temperature, the more that we sell ice cream. Reasonable enough? Usually people say yes. Okay. There's a correlation. There's a correlation or a relationship between that and that. There's a correlation between temperature and sales. Okay, what is this telling you? More money, no problems. It's actually true though. More money, the more money we come across, the more problems we see. Okay, positive correlation. Cool. Okay, so what are you actually going to look at? Those are called scatter plots. A scatter plot is a graph that relates 2 different sets of data by displaying them as ordered pairs. There's your definition. There's your definition. Scatter plot. Most scatter plots are in the first quadrant. That's because usually we're talking about positive values. They don't have to be, but they are most of the time. So again, you've been making scatter plots for a very long time. Scatter plots help you find trends because it's a nice picture. A lot of times with graphs, we can get a quick sense of the picture. Like without even looking at the numbers, you all could have told me higher temperature, higher sales. Okay, same kind of thing here. Now they have NIGs. Okay, so this graph right here, what is happening? As X goes up, what is happening to Y? So would it shock you that this is referred to as a positive correlation? Good, it's not supposed to. Okay, that's an example of a positive correlation. Okay, and I'm just going to indicate, even though they have the words, X goes up, Y goes up. So what do you think this next graph is showing? Yeah. X goes up, what happens to Y? Y goes down. There are things that are negatively correlated. As this goes up, this goes down. What's the last one? Random. What? Somebody else said it. No correlation. No relationship between X and Y. It is random. We can't say random, although we could think of it that way. Okay, but it is no correlation. Sometimes things aren't related. Like if I collected all of your shoe sizes, because you know how much I love shoes, and the temperature outside, and I plotted them as ordered pairs, I could do it. Would you expect any kind of relationship between them? No, I hope not. Okay, no relation. So you can graph any variables you want. That doesn't mean they're going to be related. Or, what is our fancy word for today? Correlated. When things are correlated, they're related. Okay, and then one thing usually kind of helps with the other one. Okay, so let's look at an example you should hopefully know, maybe from life. Okay, don't look at the paper. Look up here at the board, actually, because they already had the picture of the graph. This table shows the relationship between altitude and temperature. Just based on what you know about life, what is supposed to happen to the temperature as you go up higher? What is supposed to happen? It's supposed to get colder, isn't it? Yeah. So altitude goes up, temperature is supposed to go down. So the graph looks like that. Does that graph shock you now that you've seen it? Really? Not supposed to. What kind of correlation is this? We just learned this. Negative correlation. Okay, as altitude increases, temperature decreases. So there are relationships between so many variables out there. Sometimes they're positively correlated, sometimes they're negatively correlated, sometimes they're not related at all. Okay, and that's what we're going to kind of see as the next 2 days unfold. Okay, so let's look at this example. We're going to do a little of this stuff by hand. We don't need the calculator for a little bit, and then we need the calculator. This is the relationship between dollars spent and gallons of gasoline purchased. Okay, we'll fill this first part in together. So if X represents the dollars spent, what does Y represent? Gallons what? Perfect. Fill that in, and then I want you to plot these points, all of them. Plot those points. Is that Evan Mobley jersey? Yeah, one of them is weird, but that's okay. Ultimately, it should look like this. Don't forget to put gallons here on the y-axis. How'd the plotting go, okay? Yeah. Make your third grade self proud or whatever it was. Which point might seem a little strange to you? 10? How could you possibly, though you can raise your hand for this, how could you possibly spend $10 and get two different amounts of gasoline? Marshall?
Because diesel and regular gasoline.
Okay, it could be different kinds of gas. Could be rounded. Gas prices change like every 5 seconds. Like the gas prices at the gas station on the way to work today might be different than the ones on the way home. So I could spend $10. Actually, have you ever seen two gas stations have like different prices, like across the street from each other?
Yeah.
That's actually a thing. So that's how you could spend $10 and get two different amounts. Okay, cool. The graph looks good?
Yeah.
Okay, we're going somewhere with this. But let's answer these questions. Not supposed to be hard. So the number of gallons bought tends to increase as the number of dollars spent also increases. What kind of correlation are we talking here? Okay, piece of cake so far. Well, now it's going to get messy, but it's going to be very, very doable. So easy question. Probably the easiest of the day. That graph, is it linear? Supposed to be easy. No, definitely not. There's not a way to draw one line and hit them all. Okay, but is it kind of linear? Yes. Okay, that's something you have to think about. When two sets of data have a positive or negative correlation, you can use a trend line to show the correlation more clearly. A trend line is a line on a scatter plot drawn near the points that shows a correlation. That's what it needs to be, a trend line. I'm going to make the bold prediction, none of this gets done in pre-algebra. I don't know why she would do this. We're going to work on drawing trend lines today. Now, something I want you to make this note like right near this graph. You have these pictures, yeah?
Yeah.
Can you make this note? The line is not really there. A lot of students have a hard time with this over the years, so I figured I would just put it out there. The line is not really there. You are drawing in the line to show the trend. It's not real. Okay, it's just a model that you pick. The points are there, the line is something you draw. Okay? So let's talk about these pictures. Another easy question. Is the line perfect? Does it go through all the points? It can't. There is no line that can go through all those red points. And if you start moving it around, it's not a line anymore. So how did they draw the line? Well, they tried to draw it in a way where it's not too far away from any of the points. They actually tried to balance the points as best they could. Let's look at this line. So it goes through like 2 points. How many do they have like above it? How many below? That's the best they could do. They drew a line that isn't too far, okay, where it kind of approximated the points. Same idea here. This only went through 1 point, but what do you notice? 4 below, 5 above is probably the best that they could do. You're going to realize as you do this, there is no perfect answer, but you need to draw one in that doesn't leave any of them out. So are you going to be doing a lot of this? Yeah, you are. Okay? Until I show you what to do with the calculator. Okay, that's going to be part of it. Drawing in a trend line takes a little practice. Now, why would we ever want to draw a trend line? It's for what we do next. But let's come back to that. Let's actually do one now. So what I want you to do is I want you to take your ruler on your graph, go on back to your graph that you made, and I want you to try to draw in a line that you think best balances those points as best as humanly possible. And we're not all going to draw the same line, but that's okay. They should all be fairly close. Let's just go hand up when you've drawn your line in. Just like, psh, there you go. We'll talk about your line. Okay. So, a couple questions. Okay, let's go back to this. Let's say it again. Are we all going to draw the same line? No, but they've got to be close. There's no way that our slopes should be so different. Marshall, you put your hand down now. Okay, that I can't, get it fairly close. Okay. Question, there's not a wrong answer to this, but I'm just kind of curious. How many of you had your line start at the origin? Put them up, 0, 0. I think I know why you did that, because if you spend $0, finish my thought, you don't get any gas, okay? Who didn't draw their line through the origin? Put them up. Come on, everybody's got to answer, okay? You either did or you did not. Let's go back to the first one. No, people just have to answer. I'm tired of this. Put your hand up if you did draw through the origin. Put them up proud. Okay, so not as many people raised their hand a minute ago. Put it up if you did not. Okay, here's the good news. It doesn't matter, but I can make the argument that I can get a better line by not going through the origin. Okay, we'll talk about that in just a second. So, are you going to have to play around with the ruler a little bit as you work through these on homework? Yes. Okay, you're going to have to, first let's take the ruler off. Okay, that's how my ruler's break. Are you going to have to take some time, line them up, and kind of get the feel? Yeah. Okay, but you'll get better at it. So let's talk about the lines that you draw and whether or not they're any good. Okay, so here's the one that I drew. And I'm not saying mine is right. I'm saying mine is very good. But I've also had it for a very long time. As you look at my line, is it too far away from any of the points? No. Okay? Does it hit any of them perfectly? Yeah. How many above? How many below? Does anybody want to argue my line's no good? My line's good. My line is good. Okay, I promise. Okay. Did I go through the origin? No. So you're going to learn this very quickly in a moment. Nobody said you have to go through the origin. You can draw your y-intercept anywhere you want as long as it is an accurate model. Mine is a pretty good model. Now, can I find the equation of mine? I hope so. We just took a test on this. Let's estimate my y-intercept. What do you think it is? 0.2? 0.25? Let's just call it 0.25. We're estimating all of these. Can I find the slope? Gosh, I hope so. We just took a test on this. What would I need? 2 points? Bada bing, bada boom. Ooh, what's my x change? Don't fall for it this time. 4. Don't fall for this. What's my y change? Look how many of you fixed it. You said 2, then you looked at the scale and you realized 1. What is my slope? It's a quarter. Bada bing. This is actually a pretty good model. Now look at your line. I'll bet it's not the same one. So when you do this on a test, yeah, there will be a variety of answers. They all have to be fairly close. If I think the slope is a quarter, your slope can't be like 10. It's not going to work. Okay, so when you do this stuff by hand, there's a little bit of variance of it. Okay? Now why would we ever want to draw a line? Go back to your vocab. Is that one of mine? Why would we ever want to draw a line? To make predictions. Trend lines help us estimate a value either between or outside. The first kind of estimating is called interpolation. That is where you estimate a value between two known values. You're actually really good at this. You just don't know it. I know you know how to interpolate. You do it in pre-algebra. You probably did it before. What does it mean? Well, let's look at my model. If I wanted to predict how much gas I could buy for $7, how would you use my model? Talk about it as a table. How would you use my model to predict how much gas you could buy for $7? Now, here's the best part. I'm not going to make you write this out. I know she made you write out in words how to do this stuff. Remember? Okay. What would you do? Just tell me. You would go to what? Where? And then go up to the line. Doesn't she make you write that out in words? Yeah, okay. But that's the whole point. Why is that called interpolate? Marshall, put my ruler down. I can't have the propeller stuff. That's how they break. Okay. That's the whole point. That's interpolation. It's easy to do because it's in between two known values, and then you can predict. You've been doing that for a long time. The last kind, what's that big fancy word? What's that last fancy word that you have? Extrapolation. This is so much harder. Predicting a value outside of what you know. This is so much harder because you don't know what's going to go on with the data in the future. Extrapolation is harder. It's doable. It's very hard. So what if I ask you to use my model to predict how much gas I could buy for $25? Could you do it?
Yeah.
Could it be wrong because it's so far away? Yeah, it's harder to do that. Okay, it's easier to predict within what you know. It's harder to predict what's going to happen like way down here. Okay? But the whole reason we draw these lines in, it's not because I'm asking you to do it. It's because it helps us make predictions for data that's not actually linear. Okay? Now, this note is important. That's why you don't have to write it. I wrote it for you. When drawing in your trend line, the whole point of today, you're trying to draw one in that balances the points. Usually the same amount above as below. And you may get a y-intercept that does not make sense, but that's okay. It's just a model. Okay, so we're going to do kind of one more by hand, and then I'll show you how the calculator can do all this for you. But you have to know how to do it by hand as well. Let's look at the Panda data. We have age in months, weight in pounds. So they took all of those ordered pairs, they plotted them for you. Nice positive trend. As X goes up, Y goes up. You tell me, how's the line that they drew? Pretty good?
Yeah.
I hope so, it's the book. It better be good, okay? What about their y-intercept? Where is it? It is negative. Yeah, negative something. If this is the y-axis, this is the x-axis. Isn't their y-intercept, isn't it down here? Slightly below? Does it matter? No, I tried to tell you, it does not matter at all. You just need an accurate line. So start that wherever you go. Okay? Cool. Now, last one by hand, and then I'm going to show you the fun stuff on the calculator that you need. So I want you to do, we're going to have you do all this. I want you to plot these points. I want you to draw in a trend line like we just did, one that you think is good. And I also want you to try to write the equation for it. Go ahead, so take you a minute or two. We don't need the calculator for this. This should be that. The calculator is coming. You do have to know how to do it without the calculator, and in addition to with. That's why we're doing that first. You're going to have to estimate where a couple of these are, but that's okay. Notice they went right from 6 to 8, and that wasn't even me. That's like this book has been around for 10 years. They even knew back then to skip the number between. I know. How about that, huh? Plot the points. Use your ruler to draw in a line. Little advice. Maybe don't draw the line in like the darkest possible in case you want to erase it. And then I want you to find the equation for your line as well. And then I'll show you how to save a lot of time. Well, that's a good thing. I hope the plotting looks good. Maybe? How many of you started at the origin for your line? Okay, good. Wouldn't it be hard this time? I think if I start at the origin, I don't think that's a particularly good line. So that's why you can start it wherever you want. I think if you even just start at 5, did anybody just start at 5? You can get a much better line if you just start at 5 and then play with the ruler and then get it there. Okay, I actually think some people started just a bit above. Some people start like around like 7. Yeah, you can get a really good line if you do that. Okay, so I drew that kind of line right there. Looks fairly good to me. And then I could find an equation and I could work for it. Okay, so I'll go off of mine. You can go off of yours. Okay, how does my line look to you right now? Pretty good. Okay, no one's too far away. I'm going to estimate the y-intercept. What do you want to call that? 6 or 7?
Yeah,
Let's call it 6. Don't worry. Stay tuned. How do I find my slope? Come on, you just took a whole test on this. 2 points. X change, Y change. Looks like my X change is 2. My Y change is 5. Don't fall for the scale. So I got a slope of about 2.5. So my equation is 6 plus 2.5x. Now let's talk about everybody's question. They're like, well, I got this, I got that. Remember, I would have to take a slight variance on the test. We're all going to draw different lines. But my slope is 2.5. You think your slope can be like 8? No, it's got to be in the ballpark. Okay? So that's what I'm going to roll with. It works for me. I'm going to use my equation, then we'll get to the graphing calculator. So my equation was y, and you can just use mine if you want, but you got yours as well. Y equals 6 plus 2.5x, somewhere in that ballpark. Now we can do whatever we want. Use the equation to predict the body length of a 7-month-old panda. I would just replace x with 7. And you all have calculators. Somebody can tell me what my answer would be. I would think so, Mike. If you know it, then just tell me. 20, is it 22.5-ish? Okay. Cool. But these models have their limits. Do you think I could use this model to extrapolate the body length of a 3-year-old panda? It's too far away. What do you know about growth? At some point it stops. Actually, what happens at some point, you know this, right? Yeah, she shrink a little bit, okay? So, as fun as the model is, at some point it'll stop. You usually grow the most, like when you're young, and then at some point you stop. Like, I'm the same height as I was when I was in 8th grade, sadly. That's the way it goes. Happens. I was a forward, and then my basketball coach said, either quit or learn how to become a guard. So I became a point guard. That's the way it is. Okay. But this is not a good model to use now. I mean, in the future, 3 years from now, who knows what it would look like. Okay. All right. Now it's time to do this calculator style. Now I'm going to tell you the same thing I tell every group. I'll probably show it twice. I'm not going to fix your individual screens. Like, you need to kind of follow along. Best advice, the first time I tell you to push the button, you push that button. Okay? So open up the calculator. If you're using mine, please keep them flat on the desk so no one else drops them on the ground. You should have already cleared the memory. If you ever don't clear the memory, don't be surprised if there's something random throwing it off. Okay? When you clear the memory, that gives you a fresh start, and then you're good to go. Now, some of what I show you today you've done. Some of it you definitely haven't done. Okay? So I cleared the memory. I'm good to go. We are going to do, let's do the problem we just did. Okay? Let's do the original panda data. Okay, so I want you to be opened up to the graph that you just made, and we're going to input this data into a list. We're going to hit stat. We're going to pick the first one, which is edit. That brings up this screen. Hand up if you remember this screen. Feel like I know what you did with it. Didn't she do the thing where she showed you how to make a box and whisker or do quartiles? Yeah, that was this screen. Okay? Now, what we do with it, you didn't do. Okay? And I promise that. Okay, now you should be able to do this a little bit quicker than me because typing up there it takes forever and I'll be reading off here. Okay, in list 1, we're going to put the X values for the panda. Okay, so I think they go 1, you can do this, 2, 3, 4, 5, 6, and then they jump right to 8, 9. And that wasn't even me, that was the textbook, I promise. This book is 10 years old, they knew. Thumb up when you have the X values in list 1. Okay. I'm pretty sure she did this with you, then she showed you how to make like quartiles and all that jazz. Okay? You're going to arrow over to the right to list 2. Any wild ideas what's going to go in list 2? The Y values. Now they have to line up. So I'm looking at your exact data. Who did 1 line up with? 8? 2 lined up with what?
11.7.
Good. Okay, I'm not going to read the rest. Go ahead and fill in the Y values. And I'm getting these right off your page. They're the same ones that you have in front of you. You don't have to wait for me. You should actually finish before me. Because it takes me forever to type up here, and I usually miss a decimal point or something. Same thing. Thumb up when you have this in front of you. You get a chance to practice this yet again. Promise it'll be worth it. Okay, so there's actually a way to get the graphing calculator to plot these points, like as points, and not like a line. But if you hit graph, that's not going to show up. Okay, that's not going to show up at all. There it is. That's not going to do it. Even if you adjust your window, it doesn't show up. In fact, let's adjust the window now. So hit window. Let's see, what's our lowest X? Is it 1? So I don't know, what do you want to go for? 0 to, what's your highest X? 9? So what should we do? Steven? Oh, even? Let's go like 15. Give yourself some breathing room. Okay, don't worry about the scale. What's the lowest Y we have? 8? So let's go 0 again. What's the highest Y? So what should we do? Good, yeah, give yourself a little room to breathe. So you adjust the window, you hit graph, nothing shows up. Somebody in period 2 remembered this, I was impressed. There's a way to get the graphing calculator to show those points, but you have to do something. Anybody know what it is? I was surprised that this person, anybody knew.
Is it Zoom?
It's not Zoom. Oh, we got 2 people that remember. You're not going to hit Y equals. You're going to hit second Y equals. That brings up this screen. You have to turn on what are called stat plots. And every time you reset the calculator, these go back off. So I want you to, where it says plot 1 off, hit enter, turn it on. Now let's look at this screen. Did she do the box and whisker with you? I mean, I know she did with some people, at least the list, okay? Look at all the graphs you can make. That's a scatter plot. That's what we're going to do now. It's a line graph. What's that? It's not a bar graph, but it's a kind of bar graph. Instagram. Whoever said that, nice job. Oh, there's the box and whisker plots with outliers. Another line graph. Okay, we don't need it. We'll keep the first one. Are our X values in list 1?
Yeah.
Cool. Are our Y values in list 2?
Yeah.
Cool. Now hit graph. Thumb up if you have that. That's what you should have. So if you don't turn the stat plot on, nothing will show up. If you do, it'll plot the individual points. Okay, that's the panda data that you just plotted a few minutes ago. Okay? Questions so far? Yeah. We're not going to trace. We're going to actually get them to create. Not only are we going to get them to create the perfect line, we're going to get them to graph it for us. Okay? Now this next step is probably new. Like I know it is. We're going to run what's called a regression. A regression is a calculator term for they find the perfect line. Hit stat. You're going to arrow to the right 1 spot to calc. See, I think she might have shown you this. That's where you get all the stats, but nonetheless. You're going to go down to 4. You can either push 4 or you can arrow down to 4. Brings up this screen. We are going to run what's called a linear regression. This is such a big moment, your first regression. I should like take a picture for all of you. It's like such a big deal. A regression is a way that the calculator averages pretty much everything together and they make the perfect line. Better than you can make, better than I can make. It does it all. Okay, and actually running it's not hard. So we get to this screen. Are our X values in list 1? Cool. Are our Y values in list 2? Cool. Never touch frequency list. I'll teach you about this in a minute. Just go down to calculate. You'll have your fun. Go ahead. Yeah, exactly. I know. Okay. Here's the real question. What does that mean? Talk about it as a group. What on earth does all that mean? What does that mean? Talk about it very quickly. Talk about it very quickly. Okay, what's it mean? What does it mean, Steven? A is the slope and B is the y-intercept. So the perfect equation, the best anybody could come up with, is y equals 2.5259 whatever x plus 6.72072. That's better than the equation you came up with. It's better than the equation I came up with. That's the best anybody can do. In fact, let's check it. We'll round it off. Okay, so we're going to round it off to, we didn't do this one. We did, isn't it? It's this one? Yeah, okay. We're going to round it off. So the perfect equation is y equals, what, 2.52x plus 6.72. Let's go to y equals, and let's enter that. So go y equals, and enter 2.52x plus 6.72. Hit graph. She's beautiful. Yes. Missed something. Window might be off, could be anything. That's the best that can be done. Now remember, there is no perfect line because it's not linear, but that's the best anybody can do. Okay? It's actually fairly close to mine, but I also knew what the regression was afterwards. Okay? Now, guess what? We're going to do the whole thing again, but with a different set of data. So if you missed all of that, or some of it, you get to see it one more time. But I'm going to force you all to clear the memory. So do it. Second plus 712. Everybody should have cleared the memory. Well, have to. Now, we're going to replicate it, but not with that panda data. We're going to do it with this panda data. This is like your only other shot at seeing it right now because you already have to do this for your homeworks. I would lock in, as you kids like to say. Boo. Clear the memory. What's the first step? We have to enter the data. How do we get to that screen? Stat. Nope. Stat. Edit. Gets you here. What goes in the first list? X. Now I'm doing the other panda data, the one from earlier. So you might need to flip back the page. So 1, 2, you don't have to listen to me read it, but this is what they are. 3, 4, 6. Oh, they did it again. 8. I don't know. Remember, this book is 10 years old. They must have known something at the time. Those are all the X values. Now we go to list 2. We enter the Y values. Now, and just get that entered. Now, before you go on, it is worth checking to make sure you didn't goof something up. If you goof up even one value, you miss a decimal point, something, the whole thing falls apart. Calculator starts screaming at you. I'm sure a lot of you have been yelled at by the graphing calculator before. So that is step 1. You have to enter the list, the data, the X's into list 1, the Y's into list 2. Questions about that? Okay, the next thing I would do is I would adjust the window. Our lowest X can be 0. What's the biggest x on there? 12? A lot of x's, my goodness. 15? 15 for the max. Our lowest y can be 0. What's our biggest y?
So 60.
Yeah, let's go 60. I mean, just give yourself a little room to see. Okay? 60 is fine. I hit graph. Oh no, nothing showed up. Anybody remember? Second y equals. You have to, every time you second plus 712, it turns the stat plots back off. Turn the stat plots back on. Now you should have a wonderful line or plot of points. Now we actually have to run the regression. I'm going to show you something new on this one as well. Anybody remember, you want to raise your hand and tell us how do you run the actual regression? Bella. Stat again.
Use the arrow to go
Calc. 4. Because it's a linear regression. Now I'm going to show you something new. I didn't get to show period 2 because we lost so much class. But X is list 1. Y is list 2. You're never going to touch frequency list ever. I'm going to talk about this in a moment. Just go down to calculate. That's the best Panda equation for that data. Y equals 4.92x minus 2.55 is perfect. Best we can do. I'm going to show you something. Rather than write this down, I can get the calculator to store it for me, kind of like a copy paste. Let's run the regression again. So what was it? Stat? Calc? Which one? Okay, get back to this screen. So this part's optional, but highly recommended. I'm going to go down to where it says store regression equation. What you can do is you can get the calculator to come up with it and put it in y equals for you. The way we do it is, on this line, next to clear, we hit vars, or vars, whatever you want to say. We arrow 1 over to y vars. Oh, function. We haven't seen that word in like a week. Nobody cares. Pick y1. Before I run this regression, here's what I'm telling it to do. I'm telling the calculator, okay, calculator, take all of these x values in list 1 and their y values in list 2, run a regression, which means the ruler thing, with the perfect equation, and I want you to store that equation where? Okay. Go to calculate. Looks the same. Go to y equals. It's already there. Unrounded. Unrounded. And then, when you hit graph, it's just a thing of pure beauty. It's right there. See, yes, that's the feeling that it should be. Here's what's even better. If I store the regression equation, if I ask you to predict, you could just hop to the table. You don't even have to type anything in. The table has all the values that could use to predict pretty much anything. Okay? So, now the storing of the equation is not required. Oh, wrong time to talk. So if I run the regression, this store regression equation I just showed you, if you don't remember that, it's not going to affect anything. But it does become handy. You do have to know how to run the regression. I just showed it to you like twice. Now let's say you're like a lot of 7th graders and you go home and you forget everything we talked about. That doesn't mean you don't do the homework. It doesn't mean you walk in and say I couldn't remember. You will notice in Schoology, I have the very brief in order notes of what to do. We did it twice in person, so looking at this would be the first thing you would look at. Okay, I think there's also detailed notes in there that tell you exactly what to do. So you might forget later. I mean, you wouldn't be the first, but you can't not do it just because you forget the steps. They are in there. There's also this like quick little document right there. Okay, cool. Just a couple other quick notes, and I think we're all square with this. What you just calculated is called the line of best fit. The line of best fit is the trend line. I hate when it does. I hate when it does that. Is the trend line that shows the relationship the most accurately. The calculator can always draw a better line than us, and that's not any offense to us. It just has a little bit more going on. We do the best we can with the ruler, the calculator. It does. It's got a very sophisticated way that it calculates that line. That's the line of best fit. 2.
Oh, we're leaving at 2:45.
Oh wow.
I think that's good.
They got that order wrong then. Okay. Yeah, never mind. A graphing calculator does it using a method called a linear regression. Comes in handy. We'll see as we work through it. Last thing is the last piece. Okay. Oh, it's you that's leaving it too. Wait, are you leaving there?
Yes.
All right, you leave. You leave it too. You take this Oxford too also. That's not right. The last piece, we're not going to get into this much today, but it's going to come up a lot tomorrow, okay, is the correlation coefficient. That's a number from -1 to 1, and it tells you how closely the equation models the data.
Is that sensation?
No. Correlation coefficient.
Where do you write it?
The opposite of correlation. Okay. So what this means is the correlation still has varying levels of strength. Can you just figure it out in your notebook? Yeah. It's a, people can figure it out on their own. Doesn't matter. So R tells you how strong the connection is. Just because, I don't want to hear anything. I don't care. You can figure it out. Okay, the closer R is to 1 or -1 means it's really, really close to being like perfect. Like look at this data. It's not linear, but isn't it pretty good? This has a correlation coefficient probably close to 1. 1 would be perfectly linear. This isn't perfect, but it's like pretty nice. The lowest possible value for the correlation coefficient is -1. This is pretty strongly -1. This has no correlation. Guess what the R value is pretty close to? 0. Okay? Probably pretty close to 0. Okay? But the problem is you don't actually have R. So if I look at this, okay, so let's look at our regression. Isn't that all it gave me? Yes?
Yes.
Let me show you something, okay? I want you to hit mode. Probably not a screen you spend a lot of time on. Don't you have something called stat diagnostics? Mm-hmm. Usually people say yes at this point. It's off, isn't it? I don't know why it's off. I think it should be default on, but it's off. Go ahead and turn it on. I'm going to run the regression one more time. This is your last shot at remembering how we did it. So what did we do? Stat. We already have the data. I don't have to enter the data again. How do we actually run the regression? Stat, calc, 4. Run it now. Oh, what showed up? R. R squared. We're not going to talk about R squared in this class, just R though. What did we say the highest value for R was just a minute ago? 1. That's really close to 1, isn't it?
Yeah.
Very, very close to 1. What that means is, hey, this is really, really close to being perfectly linear. In fact, I'll bet if this guy would scooch up a little bit, and this guy would scooch up a little bit, this would be almost perfectly linear. Okay, so that's actually just like another little hidden gem. When you're running these regressions, if the stat diagnostics are on, this will tell you how good it is, positive or negative, okay? Because sometimes they're not necessarily good, okay? So I know that was a lot, but you will have to run these on your homework later. If you forget the steps, which happens, please don't just say, well, I'm not doing it, okay? You can either look in the notes in your packet. I think all the notes after that are just reminders how to do it, or you can look at this little screenshot I had for you in Schoology, okay? Good. You do have about 5 minutes. Please just look at the assignment right now. Get a sense of kind of what you're getting yourself into later. Please clear the memory of my calculators before you put them back. Hopefully no more than the ground. I tried. Nothing I can do. No matter what we do, calculators will be down here.
Oh, you're so tall. I think I dropped my calculator.
And please remember, I think most of you made this note, we're not doing 9 through 12 later. We're not doing causation.